So, homework, chapter 17, question number 71. So, given a 48 kilogram block of copper at negative 12 degrees centigrade is added to 110 gram of water in a 75 gram aluminum cup. The cup and the water have an initial temperature of 4.1 degrees Celsius. Find the equilibrium temperature of the cup and its contents. What mass of ice, if any, is present when the system reaches equilibrium? Okay, right. What mass of ice? Where's the ice coming from? Oh, because the water temperature goes down when you add the very cold ice copper metal, right? So let's see. Given the mass of the copper is given, right? Mass of the copper, which is 48 grams, and temperature of the copper is given, which is negative 12 degrees Celsius, and the mass of the water is given, which is 10110 grams, and uh, okay, I would say COP for copper because there is a mass of the cup too. Mass of the cup is given as 75 grams, and the initial temperature of the water, which is tea water, is given as 4.1 degrees Celsius. Okay, so these are what's given, and you have to find the equilibrium temperature of the cup and its contents. So T, basically equilibrium temperature. Equilibrium temperature. Okay, let's see what's going to happen. First of all, we need to have the equation, the energy conservation, heat gain by the copper. Copper gain heat because it's added to the high temperature water, right? Higher than the copper temperature. Heat loss by the water. Okay, let's see the heat gained by the copper. So now mass of the copper times, what is the specific heat of the copper? Anybody know the specific heat of the copper? What? 320, 328 or 320? 328. So specific heat of copper, can somebody check that please? And then T minus Tc equals mass of water, specific heat of water, and T water minus T plus mass of the cup, specific heat of the cup, T water minus T. Okay, so now mass of the cup, okay, mass of the copper, which is 0.048 kilograms. And what is the copper specific heat again? 387. 387 joules per kilograms per Kelvin times. Now T we need, temperature of the copper is given as negative 12, right? Negative 12 degrees Celsius, which has to be equal to mass of the water, which is 0.110 kilograms times 4186 4186. Okay, now little bit confusion here because okay, so we have no clue at this point. We have a phase change taking place with the water, right? How do you find that out? If there's any phase change, because because water temperature can go below zero, right? There could be a possibility water temperature can go below zero. If the T final is go below zero, then what happened? Then it form ice. What happened when it form ice? Phase change and more heat come out of the system and added to the copper. So it gets a little bit complicated then, right? So, okay, say that uh, what mass of ice, if any, is present. If it is the case, let's keep on working like that and see what is the final temperature we get, okay? And then we decide. Okay, so times T water, temperature of the water is given as 4.1 minus T and plus mass of the cup 0.075 kilograms and aluminum 900 times 4.1 minus T. So this is the equation we have. So now if you want to distribute these terms, every term has an unknown, right? So let me distribute them. Okay, first I want to do is, can you simplify 0.048 times 387 and give me the answer? 0.048 times 387. Eighteen. 18.58 times T plus 12 equals, can you simplify 0.11 times 4186? This term here, 416.560. Okay. Oops. 460.8.5 times 4.1 minus T plus, can you simplify 0.075 times 900? 67.5 times 4.1 minus T. Now distribute it. 18.58 times T plus, what is 18.58 times 12? 223. 223 equals Now 460.5 times 4.1. 1,888. 88,888.05. Is that right? Times 460.5 t plus 67.5 times 4.1. 276.75. Which one is that? 67.5. Okay, 67.5 times t. Okay, so we are collecting all the t terms, which is 18.58 t, and you have a 1 t term here, so plus 460.5 t and another t term here plus 67.5 t, which is equal to, and the constants, 223 plus 1888.5 plus 276.75. So now I need you to add 18.58, 460.5, 67.5. I want you to add these three. Exactly. Yeah. Right. 223 has to be negative because I moved this 223 from left side to the right side. So it has to be negative. That's right. Thank you for that. What is that?
Should the 67.5 be negative too?
No, it's not. It's already negative. It's already negative on the right side. So you move it to the left side, so it's become positive. What you get if you add these three? 546.58 t, right? Is equal to sum of the right side of the equation. Two terms are positive, one term is negative. 1941.8. Good. Okay, so this is centigrade. Now T equals 1941.8 centigrade divided by 546.58. 3.55 degrees Celsius. Okay, that is our equilibrium temperature. And do you think any ice in the system? No, because final temperature do not drop under 0. Since final T does not drop below 0, no ice form in the